Hi, today we are going to talk about graphing log functions. And so to do that, the first thing that we need to remember is that log functions are really just the inverse function of exponentials. Logs and exponentials are inverses of one another. Well, let's revisit this idea of inverse. What does it mean to be the inverse of something? Let's go back to what we've talked about in the past. Remember, the inverse of something takes any ordered pair. So if we have some function that has the ordered pair AB, that in the inverse function, remember it's notated, I'm writing too high up, it's notated with the little -1 symbol, that the ordered pairs switch. So what was the x in the original becomes the y in the inverse, and what was the y in the original becomes the x in the inverse. So the domain and the range switch of inverse functions. We're going to use that idea to help us graph. So let's go back to the type of graph that we know. Let's go back and look at our exponential function. And remember, in our exponential function, we use the three ordered pairs, -1, 0, and 1. Sorry, they're not ordered pairs yet. The three x values, -1, 0, and 1. And we plug in 1 over b, 1, and b. So for this graph, we'll do it in blue, we would have 1 over 2, 1, and 2. And so when I sketch this graph, -1, 1/2, 0, 1, 1, 2, it almost looks like a line, but we know that if we were to continue on, we'd get higher and higher numbers. So 2 would be 4, 3 would be 8. I don't even have that on my graph. And remember, this graph has a horizontal asymptote. Remember, we talked about the horizontal asymptote at y equals 0. Let's also talk about our domain and our range. What is the domain of an exponential function? It's all reals. And the range goes from 0 to positive infinity. We cannot include 0 because that's where we have that horizontal asymptote. So now that we know our exponential function is really just an inverse of a log function, I'm going to start to look at the idea of log functions. Remember also, for inverses, when we want to find an inverse, we switch the x and the y and then solve for y. So that's what we've done here. We've taken this function, this parent function that we just graphed in blue, and we switched our x and our y. The problem is we don't have a way to solve for y yet. Okay, so since we don't have a way to solve for y, and this makes it a little bit trickier, I know that these are inverse functions, so I'm going to switch all of my x values and make them my y values. And then what I'm going to do is I'm going to take all my y values and I'm going to make them my x values. So I'm going to go ahead and graph this one. Let's do it in a different color. Let's do it in purple. This will be 1/2, 1, and 2. And if I plot these points, x is 1/2, y is -1, x is 1, y is 0, x is 2, y is 1. I would even have the point x is 4, y is 2, just like we did over there. And so when I sketch this graph looks like this. Now, is there a way I can get a negative number? I cannot use a negative x value. So just like I had a horizontal asymptote for exponential, I am going to have a vertical asymptote for logs. So we have a vertical asymptote. Our vertical asymptote is at x equals 0 for logs. What about our domain and our range? Well, this time my domain needs to be greater than 0. And my range needs to be between -infinity and infinity, or all reals. So what was my domain for my exponential is now my range for my log. And what was my range for my exponential is now my domain for my logs. Okay, so let's look at that and how we write this and how we deal with the parent function for logs. The parent function for logs is going to be just like that graph that we just did. I am going to take -1 is going to be 1 over the b value. 0 for y is going to make it 1 for x. And 1 for my y makes the x b. The b that we're going to be referencing in this problem is going to be that base of the log right there. And so when I sketch this graph, I don't really know what b is, and the parent function is going to differ regarding based on whatever that base happens to be. So we'll call this 1, we'll call this b. My graph is going to look something like 1 over b -1, 0, 1, and 1b. We'll call this 1. And my graph is going to look like this. We are going to have a vertical asymptote, and that's going to be important. Now, just like with every parent function, you guys, we are going to work on our shifts. We have translations that we can make. Let's review what we know. We know when we are looking at our parent function, this a value is important. What does a do? Remember, a is our stretch or our shrink. So a equals the stretch or the shrink. What about h? What does h do? That's right. H shifts the graph left or right. And then what does k do? K is up and down. So when I start with these transformations, when I deal with this parent function here is how I'm going to go about graphing it. The first thing I'm going to do when I sketch these graphs is I am going to start with the parent function. So I'm going to start with this log base 2 of x. I'm not going to do anything else. I'm going to start with that log base 2 of x. So let's look at what that looks like. I would make a table of values using that parent function. So -1, 0, 1. And remember, it's 1 over b. So my base is 2, so -1 is going to be 1 over 2. 0 is going to be, when y is 0, x is going to be 1. And when y is 1, x is going to be 2, or the b value. So if I were to sketch these, I'll do this in gray to start with. If I were to sketch these, I would have 1/2 -1, 0, 1, 2, 1. Oh, I said that backwards. 1, 0, sorry, 2, 1. And this is what my graph would look like. I know I have a vertical asymptote here at this line. Okay. I'm going to actually, let's erase all the red just so it doesn't get confusing with what we've already done. Let's do it a lighter shade. So let's graph this in red. Oh, it's not much lighter. A little bit. Okay, there's my vertical asymptote. Now what I want to do is I want to look at my function transformations. What does the -3 in the parenthesis tell me? What does the +1 tell me? It tells me I'm going to go right 3 and up 1. So I'm going to take each of those parent function points and I'm going to move right 1, 2, 3 and up 1. I'm going to move right 1, 2, 3, up 1. I'm going to move right 1, 2, 3, up 1. Now, what else needs to move? My vertical asymptote has to move. It also has to move right 3, up 1. Now, the up 1 I'm not going to really be able to tell, but the right 3 I will be able to tell. So I'm going to graph that vertical asymptote right 3. And then I can sketch my graph. Now you might ask, do I have to sketch in the vertical asymptote? The answer is no, it's not actually a line, but it is a good visual reminder that your graph does not go below 3, because if your graph goes below 3, then it's not correct. So let's talk about what we know. We know our vertical asymptote is now at x equals +3. It's shifted right 3. My domain of this function needs to be 3 or greater. And you could certainly say x needs to be greater than 3. That's fine too. And my range, what is my range? For log graphs, my range is all reals. All right, so hit pause and try the next one. All right, hopefully you had a chance to try this one. So let's start by looking at my parent function. My parent function is going to be based on that log base 5. So I'm going to make a table of values using that base of 5. So in this case, when y is -1, x would be 1/5. When y is 0, x would be 1. When y is 1, x would be 5. And if I were to sketch this graph, 1/5 is really hard to go, so just do the best you can. We know that doesn't graph perfectly, so I have this graph that looks like this. Keep in mind we also have that vertical asymptote at x equals 0 that we'll come back to. But what do my transformations tell me I need to do? These transformations tell me I need to go left 2 and then down 3. So I'm going to go left 2, down 3. So I'm going to take each of those points. Left 2, 1, 2, down 1, 2, 3. Left 2, down 1, 2, 3. Left 2, down 1, 2, 3. And there are my points. What else needs to shift? That's right, my vertical asymptote needs to shift left 2, down 3. Now down 3 we're not going to see much of a difference, but the left 2 we certainly are. And then I can sketch my graph through those points. So let's talk about what we have. We have a vertical asymptote at the line, x equals -2. We've shifted left 2. My domain, that vertical asymptote and the domain are so closely related. My domain needs to go from -2 to infinity. And then the range is the easiest one, is all reals. All right, hopefully that makes sense. Hopefully you guys are seeing these patterns of these transformations. Every graph we've done so far, absolute value, quadratics, what else did we do? Cube roots, square roots. Now we're dealing with log functions, exponential functions. They all have those same transformations. So if we can feel comfortable with the parent functions, then the rest moves the exact same way. All right, you guys have a good day.